Hi class, welcome to our last lesson for Chapter 12. We're on 12.6, Permutations and Combinations. Sometimes the most difficult part of this lesson is to determine whether a situation is a permutation or determine whether a situation is a combination. So let's define both of those terms. A permutation is where the order matters when there's an arrangement of objects. So the order, again, matters. Our calculator is going to define us how many combinations or possibilities there are. Here is how you would do it by longhand. We won't be using that today, but you might get that on like a standardized test or something like that. So I'll talk about it. It's n factorial divided by n minus r factorial. And a combination is an unordered arrangement of objects. So that's when the order does not matter. So now there's a couple different hints about how we can determine whether it's a permutation or a combination. One thing that's kind of nice about these is a permutation, you oftentimes see the word place. If you have a placement of things in a row or in a seat in a desk or something like that, if you arrange them in a certain place, if you're placing them, as you can tell, P, that's a good hint that it's going to be a permutation. Whereas a combination oftentimes uses the language choose. If you're going to choose 7 people out of 10, the order doesn't matter in which way you choose them, it's going to be a combination. So I'm not saying that it works every time, but if you're kind of stuck about where to go, if it says placement, it's going to be a permutation. If it says choose, it's going to be a combination. Again, not every single time, but a lot of times. On our calculator, here's how we're going to find permutations and combinations. And I will again define this as we go through the questions. So let's just see whether these situations are permutations or combinations coming up in this first exercise. Letter A, your teacher tells you to answer 4 of 6 questions on an essay exam. Now, does it matter if you answer question 1 and then question 4 and then question 6? Or does it matter if you answer question 4 first and then 1 and then 6? The answer is no, it doesn't matter. If it doesn't matter, it's a combination. It doesn't matter what order of which you answer those essay questions. Now, if you choose 5 of 8 people to sit in assigned seats at a concert, does it matter if you sit in the first row as compared to the 10th row, as compared to the 20th row? Does that matter? Absolutely it does. This one is going to be a permutation. This one's going to be a permutation. Letter C, if you choose 4 of 20 people to serve on a subcommittee. Now on a committee, especially a subcommittee, they all have the exact same role. They're all making decisions on behalf of a group. Not one voice is more powerful than another. If it's a subcommittee, it doesn't matter if you're the first person chosen on that group or the third person or the fourth person. You all have the same role. So the order doesn't matter. It's going to be a combination. However, if you serve as officers of a committee, now one is president, now one is vice president, now one is secretary, now one is the treasurer, something like that. Those different jobs, they matter which one you are. So this one is going to be a permutation. Permutation for that one. Here we go, letter E, choose 3 people in a class of 25 to receive a Hershey kiss. So the first person is going to get a kiss, and then the second person chosen is going to get a Hershey's kiss, and then the third person is going to get a Hershey's kiss. If you were one of the 3 chosen, does it matter to you if you were the first person, or the third person, or the second person, whatever? It doesn't, does it? You all get the exact same prize. So it doesn't matter if you're chosen first, or second, or third. This is going to be a combination. On letter F, though, choose 3 people in a class 25. One will receive a Hershey kiss, the other will receive a Snickers, and the other will receive a Kit Kat. Well, now the order does matter, because if you're chosen first, of course you're going to choose the Snickers, because the Snickers is the best candy up there, of course. And then the Kit Kat is the second best candy, so the second person is going to get the Kit Kat, and then the third person is going to get the Hershey Kiss. You want to be the first person chosen. You want to get that number 1 spot. If that matters to you, it's going to be a permutation. So there's our answer for letter F. Hopefully those make sense to you. Again, sometimes the hardest part is determine whether it's a permutation or whether it's a combination. All right, Susie, she has 7 different scents of lotion that she is going to place in a row on a shelf. How many ways can this be done if all 7 of them will be placed? So class, here's what's happening. There's 1, 2, 3, 4, 5, 6, 7 different scents of lotion that she wants to put on a shelf. Now she is placing them on a shelf. she is placing them on a shelf. This is where the order matters, because once, let's say one of the scents is strawberry. If she puts strawberry here, she cannot put it here or here or here or here or anywhere else. Once she places it one spot, it's stuck there. So when that happens, when you're placing them on a certain shelf or in a row or something like that, it's going to be a permutation every single time. So there's a couple different ways that you could solve this one. How many different possibilities of lotions could she put right here? There's 7 of them. Now in the next spot, how many different possibilities could she put in this spot? Well, after she placed one of the lotions, now there's only 6. And then in this one, there's 5 different lotions. And 4, 3, 2, 1. It's very similar now to and probability. It's how many possibilities are here? 7 and 6 and then 5, 4, 3, 2, 1. What you're doing is you're multiplying all these numbers together. 7 times 6 times 4 times 3 times 2 times 1. You can multiply all these in your calculator. A quicker way of doing that is by doing the 7 factorial. Factorial means it's 7 times 6 times 5 times 4 all the way down to 1. 13 factorial means it's 13 times 12 times 11 all the way down to 1. 115 factorial means it's 115 times 114 times 113 times 112 all the way down to 1. That's what factorial means. So you could put that in your calculator. Another thing that you can do is you can use our formula right here, the total number, and then it's going to be a combination or permutation, and then the number choosing. So here's what that means. It's a permutation. There are 7 different scents of lotion, and we're placing all 7 of them. So it's 7p7. Let's show you how to do these things in your calculator now. So take out your calculator, and here's how you do 7 factorial. You go to math. Here you have a menu, and up top here, you see probability right there. So we're going to be using that a lot this trimester, probability. So scroll over to probability, and there it is, and then you see that exclamation point on number 4. And an exclamation point in math means factorial. So you see that number 4, it's right here, and you're going to press enter right there. Ah, rats. You're supposed to push 7 first. I'm sorry, everybody. So it's 7 factorial. So you press 7, and then you go to math, scroll over to probability, go down to number 4, and there is your exclamation point. 7 factorial. There are 5,040 ways that she can place 7 cents of lotion on a shelf. 5,040. 5,040. Now this will get us the exact same answer. So watch how we do this one, class. It's 7 permutation 7. So once again, you go to your calculator and you press 7. And then once again, you're going to go to math and you're going to go to probability again. Math prob. Now you notice how number 2, everybody, this is your permutation. And number 3, this is your combination. So we're going to be using 2, 3, and 4 in this lesson. Okay? 2 is your permutation, 3 is your combination. So we're doing a permutation, so we're going to go down to number 2, and then we're going to press enter. So it's 7 permutation, and we're placing all 7 of them. So 7p7, once again, we get 5040. Okay? So it doesn't matter which way you do it. Or you can do 7 times 6 times 5 times 4 times 3 times 2 times 1. Once again, you're going to get 5,040 ways. Okay? So on your next test, you can write down this, or you can write down this, or you can write down this. Just make sure you show your work, which method you used, and then you could have the answer 5040. Okay? Okay, letter B. Only 4 of 7 will be placed. So instead of placing all 7 of them, she's only going to place 4 of them. So it is 7 times 6 times 5 times 4. You're going to multiply those ones. Or you're going to do it this way. There's 7 different kinds. It's a permutation. You're placing 4 of them. Both of these 2 methods will get you the right answer. And that right answer is 840. 840. Letter C. She wants raspberry and vanilla on either end. So there are 7 different lotions. 4, 5, 6, 7. How many possibilities can go in this spot right there? She wants raspberry or vanilla right there. So there are 2 different possibilities. Now in this spot is the other end. If there's 2 possibilities for this spot, how many possibilities are there for this spot? Just one. If she puts raspberry here, then she has to put vanilla here. If she puts raspberry here, then she has to put vanilla here. So one has 2 possibilities, the other has 1 possibility. Now there are 5 different lotions left because there's 7 total and she placed 2 of them. So it's 5, 4, 3, 2, 1. You can multiply all those numbers together, which is the same thing as taking 5 factorial. This right here is 5 factorial multiplied by 2, or 2 factorial, which 2 factorial is just 2 times 1. So there's our answer for letter 2C, 5 factorial times 2. And I shouldn't say that's your answer. That's how you get your answer. Your answer is 240 different ways. 5 factorial times 2 is 240 different ways. Okay, let's see about a different kind of question here. Your boss has told you that you need to work 3 days next week. How many ways can this be done? Well, if your boss asks, what 3 days do you want to work next week? If you say Monday, Wednesday, Friday, or if you say Wednesday, Friday, Monday, or if you say Friday, Monday, Wednesday, any of those combinations, he's going to schedule you for Monday, Wednesday, Friday, because it's all in 1 week. So the order in which you say the days does not matter. So it's going to be a combination. So if it's a combination, there's 7 days in a week, and you are choosing 3 of those days. So it's 7 combination 3. Just so you can see it one more time in the calculator, 7 combination 3. You go 7, and then you press math. You go over to probability. You go down to number 3 this time, because that's the combination. So NC, there we are, 7C, and then you're choosing 3. There are 35 different ways that you can do this. There are 35 different ways. The answer is 35. Moving on to number 4, you need to choose 4 of 7 items from column A, 3 of 8 items from column B, and 2 of 5 from column C. How many ways can this be done? Okay, it says you need to choose. You need to choose 3 of 8. You need to choose 2 of 5. So this is telling you that it's a combination, especially when it doesn't tell you what the item is. If it's not very specific or precise, it's going to be a combination. So you have to choose, there's 7 items and you got to choose 4 of them. And there are 8 items and you need to choose 3 of them. And there are 5 items and you need to choose 2 of them. When you have to choose like that, you might have a certain possibility with this one, matched up with a certain possibility of this one, matched up with a certain possibility of this one. So because that's the case, it's kind of like and probability. It's the probability of this, and this, and this. So you got to multiply all those by each other. So 7C4 is 35. And 8C3 is 56. And 5C2 is 10. So you got to multiply 35 times 56 times 10. You got to multiply all those together. And then you get 19,600. There's that many ways or different possibilities for that situation. Question number 5. You need to arrange the letters in the word almond. How many ways can this be done? One thing that's kind of nice on this one is on these type of questions, there's not as much thinking that has to be done. There's a formula, and I'm going to give it to you. Please write this down. It's the total factorial divided by the repeat factorial. So how many total letters are there in the word almond? There are 1, 2, 3, 4, 5, 6. So it's 6 factorial divided by the repeat factorial. And so if there's any letters that repeat themselves, you divide by that. And there are no letters that repeat themselves, so the answer is just 6 factorial, which 6 times 5 times 4 times 3 times 2 times 1 is 720. It's 720. The reason why we didn't divide by anything is because there were no letters that repeated themselves. That's different in number 6 for trigonometry. It's the total factorial, which there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 different letters, so it's 12 factorial. However, these t's look the exact same. So they could go in a spot and not be counted again for the next spot because they're the exact same. So we're going to divide by 2 factorial because there's 2 t's. And then there are 2 R's, so that's another 2 factorial. And then there are, let's see, 2 O's, so that's another 2 factorial. Is there anything else that repeats? I do not think so. So it's 2 factorial, 2 factorial, 2 factorial. Which if you put this in your calculator, it's the same thing as 12 factorial divided by 2 factorial is just 2 times 1. It's just 2 times 1. So it's 2 times 2 times 2, which is 8. It's 12 factorial divided by 8. 12 factorial divided by 8. A lot of different combinations here, possibilities. 59,875,200. A lot of different scenarios there. Lots of them. Okay, let's try problem number 7. Problem number 7 says, in a straight poker, a 5-card hand is dealt from a standard deck of 52 cards. How many different straight poker hands are possible? Well, when you get dealt a hand of cards, does it matter if you get dealt a 2 first, and then a 10, and then a king, and then a queen, and then a 7? Doesn't matter, does it? In fact, when I get dealt a set of cards, I just put them in my hand from smallest to largest anyway. So it doesn't matter in which way you get dealt the cards, you just rearrange them in your hand anyway. So it's going to be a combination. There's 52 cards, and there are 5 of them that you're choosing. So how many different poker hands are possible? It's 52 combination 5. If you do 52 combination 5, it's 2,598,960. Once again, a lot of different possibilities. So that's a little brief overview of permutations, combinations. We'll do some more example problems when you get to class tomorrow. It is a difficult concept. Be sure to let me know if you have any questions. Again, we'll talk through this more in class when you get here tomorrow.